The velocity v meters per second of a particle at time t is given by v is equal to 0.4 t 8 times 8 minus t. Determine whether the speed, important speed, of the particle is decreasing or increasing when t is equal to 9. Okay, we're not looking at velocity here, we're looking at speed. But if we've got v is equal to 0.4 t 8 minus t, and if we expand that, we're going to be at 0.4 times 8, which is 3.2 t, minus 0.4 t squared. The acceleration is given by dv by dt, so dv by dt will be 3.2 minus 0.8 t. So when t is 9, the acceleration will be 3.2 minus 0.8 times 9, which is minus 4 meters per second squared. And when v is equal to when t is equal to 9, v will be 3.2 times 9 minus 0.4 times 9 squared, which is minus 3.6 meters per second to the minus 1. So what we've got here, the acceleration is negative and the velocity is negative. But what is happening to the speed? Because remember, speed is a scalar quantity. So if we just look at the graph for a minute, so we can try and explain why we're going to come up with the conclusion I'm going to write down. So going to this graph, so here we have the graph of the function here. Okay, we've got a part of p moving along. So the moment v is 0, the initial acceleration is actually positive. Okay, if we move along, the velocity is positive, and we can see also the speed is increasing. So the speed will actually increase up until this point. Okay, so the acceleration is positive. Let's see if we can get that point exactly, which is t is 4. Okay, so here we have that the velocity is positive, there's no acceleration, and the speed is no longer increasing. It's going to stay momentarily stationary. Now, when t goes past 4, okay, the velocity is still positive, but the acceleration is negative, but the speed is started to increase because the acceleration is negative. So here we go, positive velocity and negative acceleration, and the speed is decreasing. Now, once we got to this point here where it changes direction, and when we get to t is equal to 9, let's see if we get there, there we go. Okay, here we have the velocity negative and the acceleration is negative, but the speed is increasing. So here, the speed is decreasing. At that point, it's momentarily 0. And here, it is the speed, which is always positive, will actually be increasing as this goes further down here. So when we've got negative velocity and negative acceleration, the speed will actually be increasing. So this GeoGebra app I'll put in the notes of the video. So as both the velocity and the acceleration are negative, we can say that the speed is increasing. All right, so it's important because the question actually says speed, and there's a copy of the graph. And like I said, I'll put the GeoGebra applet link into the notes of this video for you to look up for yourself. I hope you've understood, and I thank you very much for watching.